Hello, everyone. So today we're going to be talking about Chapter 4, Process Improvement. My name is Anthony Jimenez, and my partners are Kathleen H., Samantha H., Jiang Tao Hu, and finally Stephen J. So for the table of contents, we're going to be talking about Chapter 4. First, we're going to be starting off with Chapter 4.1, Measure of Process Efficiency. Followed by 4.2, how to choose a staffing level to meet demand. And then chapter 4.3, the offloading of bottlenecks, followed by 4.4, how to balance the process. Then chapter 4.5, the pros and cons of specialization. And finally, chapter 4.6, understanding the financial impacts of process improvement, followed by the conclusion and summary. So chapter 4.1 is the measure of process efficiency. Uh, this is one of the most important things to look at in a business from a business standpoint because the amount of income or profit you make in your business usually stems from the efficiency from your business, meaning that if you're spending too much time per customer, not attending as many as you possibly can, um, this will make your business either flourish or diminish over time. So over the next couple of years, if your process improves and is more efficient, you'll maximize the amount of profit that you could make as years come. So in order to measure the efficiency and improve upon it, if necessary, you need to know how to find that in the first place. So the way we find it, the amount of time that is used when serving a customer, you need to find the amount of time that is used when serving a customer in every aspect. The way we do this is by measuring the cost of direct labor, labor content, average labor utilization, and the idle time for your employees. So the cost of direct labor is measured by multiplying the rate at which sandwiches are made, or in this case, sandwiches, because we're talking about Subway, per customer by the seconds in 1 hour. So in this case, it would be, the rate that they're making sandwiches by 36,000, which is the seconds in an hour. And this will give you the flow rate you need for the formula. The next thing you're going to need is you're going to need to know how many employees are in each station and multiply it by their hourly wage. So as you can see right here, there are 3 stations. Assuming that 1 employee is in each station, you would multiply it by $12 because that's their hourly wage. And once you have that, you have what is needed to complete the formula and solve it. So for the cost of direct labor, it would be 3 employees times 12 because that's their hourly wage. Then you divide it by the flow rate that you end up getting, which is 78.3 customers each hour. And that'll come out to 0.46 cents per customer. The next thing we're going to be talking about is labor content. So the labor content shows how much labor is needed to complete a flow unit. The way we do this is by seeing each station that we have for the flow unit. And you see that in station 1, it takes approximately 37 seconds to tend to the customer. So this means you greet the customer, take the order, get the bread, cut it, and add the meat and the cheese. And then you send it to the second station. So for the first station, in order to do all that, you see that it takes about 4 seconds to greet the customer, 5 seconds to take out the order, etc. And then that comes up to 37 seconds. Then you end up doing the same thing for station 2 and 3. You'll see the station 2 has a couple more tasks, hence why it's 46 seconds, a bit more. They put the onions, lettuce, tomatoes, cucumbers, pickles, all the way to placing the condiments and wrapping the bag. This is assuming that the customers want everything on their sandwich. So depending on that, it could be more or less, but this is why it's the average because most customers do. And finally, we get to station 3. And once we add all that up, you see that station 1 has 37 seconds along with station 3 as well. And then station 2 has 46 seconds. And once you add all those up, you get the content labor. So you'll see that the content labor in this case is equal to 120 seconds per customer. So this calculates the total average of how long it takes for each customer to be served. Finally, or not finally, but the next thing we need to do is calculate the average labor utilization. So it's important to know this because it shows the efficiency of workers during a process. And this is, again, important, like I said in the beginning, because the better the efficiency, the more efficient your workers are at work, the more profit your business will make because they're constantly serving and making sales or helping customers faster than maybe competition is doing, other competition is doing, which means that in the day you'll probably get more profit than other people would if they just their process wasn't as fast or had a faster flow to it. So the way we do this is we obtain the utilization levels by multiplying the seconds in each section by 3,600, which is the amount of seconds in an hour. And so once we have all percentages, we multiply them to get the average labor utilization. So in this case, you see the average labor utilization is equivalent to 87%. And this is actually a good number. But you want to get it as high as you can because this means that your employees are constantly doing their work and you're paying them for that. So the higher it is, the better, the more efficient you are, so the more profit you end up making. And finally, the next thing we're going to be talking about is idle time. The idle time is the amount of time that the employee has doing nothing once the customer is sended. So in between customers, there's going to be a time when employees have nothing to do. You can see this in a lot of places, especially personally speaking for from fast food perspective, there's constantly times when there's no customers coming in. So that's considered idle time. So anyways, the way you find this is by getting the cycle time and subtracting it from the processing time. So in station 1, you'll see that the cycle time actually in all stations are roughly 46 seconds. And then you subtract it for the actual process time that they have. So in station 1 and 3, you'll see that the process time for them, the average process time would be 37 seconds, and the process time for section 2 would be 46 seconds. Once you subtract them, you get the seconds per customer for the idle time on each, and then you're going to want to add that total all up. So it would be, this case, it would be 9 plus 0 plus 9, and that would total up to 18 seconds per customer. So depending on what kind of job you have, 18 seconds could be a lot or a little bit. That might be the cause for loss in profit in a huge job or corporation, maybe like Amazon. And it might not be as detrimental, or it might be a little bit of idle time when it comes to jobs like fast food or something where there's constantly customers. It might be even 24/7. And for example, for Amazon or something, 18 seconds might be a lot because there's deadlines that each order needs to get to worldwide. And, you know, there's like millions and millions of orders that have been placed that just keep coming in. And 18 seconds could be a lot of time and could cut into the time for other process to be finished with the package. So with that being said, we're going to pass it on to chapter 4.2 with Stephen. So Stephen, take it away.
Hello, my name is Stephen Jacobo, and today I'll be going over section 2 of chapter 4 with you guys. In this section, we are going to cover how to choose a staffing level to meet demand. The learning objective of this section is to compute the talk time of a process and translate this to a target manpower. A few of the key concepts we are going to go over in this section are talk time, target manpower, and leveling demand. I'll go over each of these in more detail in the coming slides. The first one we come to is talk time. Talk time is the ratio between the available time and the quantity needing to be produced to meet demand. It should be noted that talk time is entirely derived from demand. So without demand, you cannot have talk time. As can be seen on this slide, there are two formulas that can be used to find talk time. The first of those is talk time being equal to 1 over the demand rate, and the second being talk time is equal to available time over required quantity. Now, why are there two formulas for the same thing? This can be explained by most organizations falling into one of two categories. Those being organizations that produce a good and those that produce a service. The formula on the left is more geared for organizations that produce a service. And this is because they don't really know what their demand rate is until someone walks in the door and asks for their service. This would mostly be retail stores, fast food chains, and things of the like. The formula on the right is designed for organizations that produce a good. This formula works better for them because most organizations under this umbrella have orders placed ahead of time. So when the day begins, they already know what their capacity is. They already know what they need to do to complete their goals for the day. Now, we should look at this talk time versus cycle time bullet point. There is a difference and we need to know what it is. Cycle time is derived from our process capacity, which is more of a supply thing. Furthermore, our cycle time is our flow rate, which gives us our start to finish time as well. But one thing about this is you can complete an entire process, start to finish, but that doesn't necessarily mean that anybody's going to want to buy your good or service. So just because you know how long it takes doesn't give you the same thing that talk time would. It doesn't give you the amount of time you need to know how to produce, how much time you need in each step to produce your product to meet your demand. As mentioned, talk time is completely derived from demand. So talk time is the amount of time you needed in each step of the process, which would mean each step, for example, only needs 2 minutes. If your time is going over that or below that, you need to reevaluate your process and possibly add more steps to this section, or maybe add them to another. Another thing to mention is you cannot have talk time without demand. As mentioned, you can go through your entire cycle time and find out what it is start to finish and have your numbers there. But if there is no demand rate, if there is no required quantity, you cannot find your talk time. Now, I have a short video that I would like to show you guys that's going to go into this in a little more detail.
Welcome everyone to this tutorial. Today we're going to step into the term and the definition of talk time, and we will show you how to calculate the talk time for any shop floor process. So stay tuned. Hi, my name is Martin and I'm going to explain you the term talk time today, and I will show you afterwards how you can use the talk time to improve your shop floor transparency today. So let's get started. The talk time is one of the key terms when speaking about shop floor processes and lean measures. It is most important to understand the correct calculation of the takt time, but also to know what the limits are. We will also have a few words about the cycle time in this tutorial. Make sure you have watched our previous episode about lead time on our channel. Let's assume we have to assemble a simple pen. As you can see here, we try to assemble the pen as quickly as possible. The time to assemble this pen takes 15 seconds. These 15 seconds are the actual assembly time of this pen. We call the actual assembly time the cycle time. So one important lesson learned here is that the actual assembly time you see on the shop floor is not necessarily the takt time, but the cycle time. On the other hand, the takt time is something you cannot necessarily see on the shop floor unless we know a bit more about the customer requests and demand. So let's see what the takt time is. The takt time is highly linked to the customer orders and can only be defined if any customer orders exist. In this case, let's ask Jack from our sales department on what the actual demand is. As Jack hands over all customer requests to our shop floor team, he perfectly knows the customer demand. For today, our customer demands 960 pens from our factory. The demand of 960 pens is one of the two figures we must know in order to calculate the takt time. So we have to know the demand, but we also have to know the available working time. So let's ask Daniel from the production department about the shift models and working times. Daniel is production manager and responsible to schedule the different shifts in the pen factory. Today the factory produced just one shift. The shift consists of 8 hours of working time. This is very important to know. With the help of Jack and Daniel, we are finally able to calculate the takt time. The takt time is the period of time in which we have to produce one pen in order to fulfill the customer request within the available working time. The calculation of the takt time is as follows. The takt time equals the available working time divided by the customer demand. In this case, the takt time is 8 hours of working time divided by 960 pens as requested by the customer. In other words, the takt time is 30 seconds per pen. Hence, in order to fulfill the customer request of 960 pens, we have to produce one pen every 30 seconds for the next 8 hours. If we compare the takt time of 30 seconds with the cycle time of 15 seconds, it is pretty clear that both numbers are completely different and based on different figures. It is very important that you do not mix up the cycle time, mostly visual on the shop floor, with the takt time, which is driven by the customer demand. Therefore, it is most important for the shop floor to align the cycle time to the takt time, either by decreasing the available working time, by proper planning of the workforce, or by shifting work contents between different stations or products. As long as the cycle time does not match the takt time, you either cause overproduction or fail to fulfill the customer request. For that reason, many manufacturers use monitors to visualize the actual number of assembled parts compared to the planned number of parts. The planned number of parts increases every 30 seconds automatically depending on the takt time, whereas the actual number of parts increase every time a product has been assembled according to the cycle time. By doing so, it is pretty transparent to see if we work according to the customer demand or deviate from it. Many thanks for watching this episode. Please tell us in the comments below what lean tool you want to see in the next episode, and make sure to hit the subscribe button to stay updated with the next episodes. See you next time. Welcome everyone to this tutorial. Today we're going
Okay, I hope that video was informational and helped you understand those concepts a little better. Now, once we understand takt time and what it is used for, we need to take that and use it to find what our target manpower is. What is target manpower? Target manpower is the ratio between takt time and the amount of employees needed to complete our goals for the day. And this is really important because we always want to ensure that we have the correct amount of staff so that we can reach our goals. We don't want too many because that'll cut into our profits, and we don't want too few because then we risk not reaching our goals for the day. As you can see here, target manpower also has two formulas. The first being target manpower being equal to labor content over takt time, and the second where capacity is equal to M, which is a number of needed employees over processing time. I'd like to take 1 second to make a note for you guys. In these two formulas, labor content and processing time, they mean the same thing. They're both just the amount of time it takes for the process to go from beginning to end. So don't be confused by that. And again, why do we have two? This is the same reason that we have two formulas for talk time. The formula on the left is geared for organizations that produce a service, and the formula on the right is for organizations that produce a good. It's easy to see the difference in these two because the formula on the right starts with capacity. This is for the organizations that already know what they need to produce for the day, and they just need to figure out how many people they need to get to that goal. But what do you do when demand is not always the same? As consumers, we know that demand is always changing, can change from hour to hour, day to day, or time of the year. So what managers need to do to account for this is they need to level the demand. Leveling the demand is finding an expected level of demand, and then you staff to that amount. The way they do this is managers will look to the past. They will see how much demand did we have on this time frame on this day or during this month of the year. So they'll look to the past and they will determine these numbers, and they will also look at growing trends. Maybe last year during that time of the year or that day of the week, there wasn't very much demand, but in recent days or weeks, those timeframes have been a lot busier. So a manager will take all of this into account, and they will set a level of demand that they believe will be sufficient. So then they will use this level of demand to create their talk time. They will then take that talk time and put it into one of these formulas, and they will find out how many people they need for that time frame. So now I've set up a few easy examples for target manpower. I would like to mention at this point in time that most often when you run these formulas, your target manpower is going to come out as a decimal. Example, say your target manpower comes out to 5.3. It's pretty obvious that you can't employ a fraction of a person. So what you would need to do is round this up to what we call our staffing level. So if it is 5.3, you either need to round up to 6 or leave it at 5. It is up to the manager to determine which of these numbers is the correct one for them and is going to help the organization best. So let's get into these examples. Let's assume a manager has already run some of the numbers and they have already found out some of the information we're going to need for these formulas. So the given information here is talk time is 2 minutes per computer, meaning that each step in the process should take about 2 minutes. And let's say our capacity for the day is 480 computers. Our labor content would be 20 minutes per computer, meaning one whole computer should be built every 20 minutes. Now let's say this organization has 2 8-hour shifts working that day. So we would have a 16-hour workday. Now, if we take the required information and we input it into the first formula on the left, we'll see that our target manpower is equal to 20 minutes per computer over 2 minutes per computer. It's easy to see that the minutes per computer portion of these equations will cancel each other out, which leaves us with 20 over 2, which would be reduced to 10. This means that our target manpower of 10 shows that we need 10 employees working at these talk times to produce our required capacity for the day. Now, if we take this same information and we put it into our other formula where we already know we want to produce 480 computers in a day, we just need to figure out how many people do we need to do that. So what we'll do is put 480 computers per day equal to M, the number of employees we need, over the 20-minute per computer processing time. Now we need to make some small calculation changes so that we have like terms on both sides, and that would give us 0.5 computers per minute. meaning that we need to produce the equivalent of half a computer every minute, and we'll set that equal to m over 20 minutes per computer. Now, again, we can see on each side of the equation, our computers per minute will cancel each other out, and that will leave us with 0.5 is equal to m over 20. Now, when we finish this equation, we can see that m comes out to 10 again. So it is easy to see that given the same information, these formulas are the same. It's just up to the organization to determine which one they actually need. Both of them are going to give them the same answer. So now if we move on and we look at talk time and target manpower in action. If we go back to a Subway example that we've used a couple times in this class, we'll see that if a manager is setting up a sandwich process line based off of talk time, our talk time of 22.5 seconds per customer and our target manpower of 5.33. The way to set up a process line based off of talk time is you will break down each step in the process and you will allot an amount of time. You will keep adding these steps together in each section until you reach your 22.5 seconds or exceed it. When you exceed it, you will take the step that puts you over and you'll add it to the next employee. So if we look at employee 1, we can see that they greet the customer, take the order, get the bread, and they cut the bread. Each of these steps takes 4 seconds, 5 seconds, 4 seconds, and 3 seconds, respectively. When you add those up, you will see that this step takes 16 seconds. But if we were to have this employee take the next step and add the meat, that'd be adding 12 seconds. Adding this 12 seconds to their already 16-second process would put them over the 22.5 second talk time. This means that adding the meat needs to be moved on down the line. The manager will then continue this process until the process has been completed, start to finish. But when you look at this process, you will see that it takes 7 employees to complete this process based off of talk time. But when we run our numbers, we get a target manpower of 5.3, which would give us a staffing level, if we round up, to 6. So you'll see that this isn't an exact science. The target manpower says that we should be able to do all of this with 6 people, when in reality, based off of our talk time assembly line, we need 7. So this is when a manager will take into account all of the time, or all of the values that we've derived from our different formulas, and make the decision on whether we want to employ 7, or if we want to do 6, or maybe even do 5. Maybe some of these people can do some of the steps in less time than what our average times are here. This is just the human part of all of this. A manager still has to make a decision. They need to take all of the information that they can and they have available to them and make the decision that is best for the organization. Which of these staffing levels is going to be the most profitable? There's work to be done there. And we will get into that a bit later. But for now, this section is complete, and I will be handing you off to my teammate. Thank you.
My name is Samantha, and I'm going to be discussing section 4.3 and 4.4. So section 4.3 is offloading the bottleneck. So offloading the bottleneck refers to the strategy of moving work or strain away from the bottleneck to improve the process and make it more efficient. So as we learned in the previous chapter, which is chapter 3, a bottleneck is defined as a source with the lowest capacity, or also known as the weakest link. This causes an interruption to the flow of work and causes delays across the entire production process. A bottleneck can be a person, a computer, department, or even a whole work stage. So if you see this picture to the bottom left, we see a road that is shaped into a bottle, just to make it a simple understanding. So if you see the 3 roads, you see that towards the right side, the lanes merge into one lane. So where the lanes merge into one would be considered the bottleneck, since only one car can pass at a time instead of 3 cars, 1 car per lane. So since that lane is holding up the traffic and slowing down the flow, it would be considered the bottleneck. And if we see this picture to the right, we see there's machine A, machine B, and machine C. Machine A has a capacity to produce 20 pieces per hour, while machine B has a capacity to produce only 5 pieces per hour, and machine C can also produce 20 pieces per hour. So in this case, machine B would be the bottleneck since it produces the least amount of pieces per hour. So there are different ways to offload the bottleneck and remove strain from that bottleneck that's holding up the process. One of the ways is to reassign activities to other resources with more capacity, such as line balancing, and we will discuss line balancing in the next section. Another way is automating some activities that are taking up time by using technology. So if we think of Pizza Hut, let's assume that employee 2 is in charge of shredding the cheese. So let's say employee 2 is considered the bottleneck since it's holding up time. It's wasting a lot of time shredding the cheese. So this employee can use an electric cheese grater instead of hand grating the cheese, which would cut down the processing time and speed up production. Another way is outsourcing some activities that are taking up time. So if we stick with the same Pizza Hut example, instead of grating the cheese during the shift while customers are coming in and ordering pizzas, it can be done at the beginning of the shift so that it makes it more efficient when customers are ordering pizza and they need to be put into the oven as fast as possible. Another way is adding more resources or people to that work stage or process. So instead of one person grating cheese, it could be 2 people. Or instead of one electric cheese grater, they could be using 2. So the next section is 4.4, which is how to balance a process. So we did see line balancing in the previous section, which we didn't go in depth about, but now we will. So line balancing is the process of allocating tasks that need to be carried out from one step to another evenly in a way that all resources have a comparable utilization level so that the production rate matches the takt time. So when we are balancing the process, there are 2 types of balancing we need to consider. One of them being balancing for a fixed sequence of activities, and the other being balancing for activities with no fixed sequence. So when it comes to balancing activities with a fixed sequence, we know that activities must be carried out in a given order, which means step by step. So step 1 needs to be completed in order for step 2 to be started. So in order to balance the process, work can be moved away from the bottleneck to a resource with excess capacity. It can be done with all other resources in order until all activities are assigned. And when it comes to balancing activities with no fixed sequence, it becomes a little bit more lenient and flexible. So if we use the Subway example that's used in the textbook, we know that we can't wrap a sub before everything is added in, but you can definitely add the lettuce before the tomatoes and vice versa. So shuffling around activities in the process gives a bit more flexibility and should lead to a higher labor utilization and lower cost of direct labor. So going on with that Subway example, so let's assume employee 1 has a lower processing time than employee 2. Employee 2 would be considered the bottleneck. So employee 1 can take on a task from employee 2, which would increase labor utilization and balance out the process because employee 1 would still have a lower processing time than employee 2. So in the next slide, I'll show an illustration explaining this. So if we see here to the left, we see employee 1 is in charge of from greeting the customer all the way to adding the cheese into the sub. So next we see employee 2 has tasks from adding in the onions all the way to wrapping and bagging the sub. And employee 3 would offer the fresh value meal all the way to ringing up at the register. So if employee 1 were to take on a task from employee 2, employee 1 would then have a higher processing time, but their processing time would still be less than employee 2. So if we see to the right, we see employee 1, after taking on the onion task from employee 2, employee's 1 processing time is now 40 seconds per unit instead of 37 seconds per unit, what it was before. And now employee 2 has a 43-second processing time instead of 46. And employee 3 would remain the same since they didn't take on any extra tasks. So this is more efficient because no matter what, employee 1 still has an overall less processing time than employee 2, which was considered the bottleneck. And now here is a video discussing bottlenecks and how to deal with them.
Today, I'm going to be talking about bottlenecks and how to deal with them. When you hear the term bottleneck, you probably think of traffic, or maybe you think of an actual bottle and its narrower neck. Those are the ways you usually hear them in normal daily life. I'm going to be talking about them in the manufacturing sense. The meaning is very similar. So, first of all, what is a bottleneck? A bottleneck is the process or the processes with the lowest output in a system. Bottlenecks can cause parts to build up between processes, the work in progress areas that you normally find between stations. Bottlenecks can cause other operators to wait and be unproductive. At the highest level too, if you can't produce enough parts for the customer, you have a bottleneck. You could lose your business with the customer. And there's many more issues associated with bottlenecks, but those are some of the main ones. So say we have a production cell with 3 stations. The first station makes 15 parts an hour. The second station only makes 10 parts an hour. And then the third and final station also makes 15 parts an hour. What station would be the bottleneck in this production cell? The bottleneck would be the station in the middle, the process that is only outputting 10 parts an hour. Because the first and third are producing more, they're not the bottlenecks. It's the center process. It has the lowest output. If you become an industrial engineer, a process engineer, a manufacturing engineer, you're going to be dealing with bottlenecks. It's going to be your job to reduce them pretty often. Even too, as another type of engineer, or as a manager, you're going to be dealing with bottlenecks. So how do you deal with a bottleneck? Well, there's a few different ways you can try. The first and most simple way that I've seen most often is just to allocate resources from other areas. You could have the employees work overtime for a little bit. You could add an employee. Or you could rotate when your employees take breaks, just so they can cover that production. You have to be careful with these methods, though. If you're going to be making the part for a long time and you have a bottleneck, you don't want to keep paying people overtime all the time. And you don't want to throw extra employees at a problem. Break rotation works decently, but that can cause issues for scheduling, and it might actually irritate the operators on the line. If I couldn't take a break with my friends, I know I'd be irritated. So really, a good way to deal with a bottleneck is going to be process improvements. This is where process engineers make their money. Ways that they can improve the process to reduce the time it takes to make a part. And a reduction in time means you can get more parts in the same amount of time. So you're increasing output and you're breaking the bottleneck. That's the terminology used with bottlenecks most often. You're breaking the bottleneck. You're improving production, in reducing the constraint in your system. So the end result is that your bottleneck production is increased. There are also secondary bottlenecks. Secondary bottlenecks are your second worst processes in your production cells, at least in terms of output they are. So your main bottleneck has the lowest output in the entire cell, the entire production line. A secondary bottleneck would have the second lowest. So say you have a scenario where your first station makes 15 parts an hour, your second 10, and your third makes 18 parts an hour. Your main bottleneck is the second station, because it can only make 10 parts an hour. It has the lowest output. But say you do some process improvement and increase the production of that station. Now we have 15, 16, and 18 parts an hour. The new bottleneck is the first station, because it now has the lowest output. So originally, it was the secondary bottleneck. Not the lowest output yet, but it will be if you improve the other bottleneck. So that's an introduction to bottlenecks and what exactly they mean and how to deal with them.
Thank you, Samantha. My name is Kathleen, and I'm going to be discussing 4.5, the pros and cons of specialization. There are two ways a manager can assign tasks to employees. The first is that each worker is in charge of all things necessary to service a client. For example, each salesperson would take care of everything from greeting the client to utilizing the cash register. This is the method that some clothing boutiques and stores use. A salesperson's goal in a clothing boutique or clothing store is to get more sales, and they handle everything the customer wants. The second option or alternative method to assigning employees to tasks is that each worker or salesperson concentrates on one or a few activities. This will increase the level of specialization, which may result in shorter handling times for each worker, which can result in an increased capacity. Option 2 is associated with higher idle time, and as a consequence, low labor utilization. Option 1, on the other hand, results in a more balanced process and hence greater labor utilization. The bottleneck in a one-employee process will be that there's only one employee. That one employee can only do so much in the same amount of time. Because the one-employee process is, by definition, a completely balanced process, we would maintain our idle time to a minimum of 0 and our labor utilization to a maximum of 100% if that employee works at 100% to his ability. A few benefits of specialization is, number 1, that there are lowered processing times owing to a removal of setups. So as a worker specializes in fewer tasks, the times for the different operations may be reduced, and therefore the capacity levels raised. So for an example of this is an individual who does all tasks may have to remove his gloves while switching from touching the sandwich or making the sandwich to running the cash register, which increases the processing time. A person who does nothing except operate the cash register, run the cash register, would not be inconvenienced in this way because they only operate the cash register. A second benefit is the reduced processing time as a result of learning. So an example is this: if you, let's say you chop a cucumber 1,000 times every day, and the odds are that you will become very good at that. And simply speaking, practice makes perfect, and that you get better at chopping the cucumbers. This perfection is reflected in reduced processing times. So this will be the subject of the learning curves. So as you get better at a task, there's reduced processing times. The third benefit is there's lower skilled work. So this means that more specialized labor generally necessitates and equals a shorter training period and is compensated at a lower rate. So for example, is like training an employee on how to build a rearview mirror takes less time than teaching them how to assemble an entire automobile. So that means the less skilled work requires less time to teach. So a shorter training period to teach the more specific tasks. And last is equipment replication. So another advantage of specialization and of the customer's process flow is a reduction in the quantity of equipment required to run the process. So even if specialization does not reduce processing times, it has the potential to reduce the denominator direct labor cost. So like wages. An example of this looks like the 6 parallel station where each employee performs all the activities would either necessitate each employee purchasing her own equipment, including an express and cash register, or it results in the interference among the 6 employees if more than one employee attempts to use similar ingredients or equipment at the same time. So this example is if you have one employee who needs their own equipment to finish the task versus 6 employees, 6 employees needing that equipment as well. So it's the 6 parallel stations. And then in summary of 4.5, we must weigh the advantages of specialization with its disadvantages, such as an increased idle time. And one of the most important features of a stimulating work environment was the employee's ability to do a variety of tasks. And after these findings were made public, many firms organized their work in work cells, and a work cell is where small teams of people execute a project from start to finish. So they complete the full complete flow unit when this research was made public. Thank you for listening, and I'm going to pass it on to Jiang Tao, and he will be discussing 4.6.
Thanks, Catherine. Hi, everyone. My name is Jiang Tao Hu, and I'm going to introduce 4.6, Understanding the Financial Impact of Process Improvement. This slide introduces the presentation whereby we get to understand the basics of the term process improvement. Here, we describe process improvement as a process of identifying an issue within an organization's business process and making alterations to meet a certain standard. We also discovered that process improvement impacts various organizational resources, such as human resources, financial resources, physical resources, and information resources. Here, we measure on one of the resources impacted by process involvement, namely the financial resource. Being one of the most important resources in an organization, understanding the impact of process improvement on financial resources is crucial. Since the main aim of any business process is to make a profit, financial resources can be defined as costs since they involve expenditures that are essential for the normal running of business operations. Financial resources are mainly divided into two categories: fixed costs and variable costs. We analyze fixed costs as a type of financial resources within a business setting. Fixed costs are defined as those which are predetermined within a specific duration and can have an impact on the financial statement at the various stages. The most common fixed costs in a business are insurance, rent, salaries, and utilities. An analysis of the other type of cost, variable cost, is made here. Variable costs are found to be hugely reliant on the organization's production or sales, unlike fixed costs, which are predetermined at an earlier phase. Variable costs vary, and their impact on the financial statement cannot be estimated due to their unpredictable nature. The types of variable costs that are common in most organizations are cost of goods and service, commissions, and wages. This slide analyzes arguably the most important income in the business world, profits. As earlier stated, the main aim of every business process is to enhance profits, hence business operations are centered around it. Before calculating the profits, another important aspect by the name flow rate needs to be determined. Flow rate generally refers to the number of flow units that pass through a business operation within a specified duration of time. Once the flow rate is determined, it is multiplied by the difference between the average price and the variable costs. The difference between the product and the fixed cost is then established to come up with the profit. So process improvements are to be judged depending on their capacity to boost profits. The final slide provides a summary of the whole chapter, for which is subdivided into 6 subtopics. Under the summary, recommendations are provided to aid in adjusting the process flow through various methods. Some of these methods include capacity building at the bottleneck, matching supply with demand based on take time, matching the internet supply with the demand through line balancing, and finding the right specialism in some process improvement is key for organizations in every sector. Organizations management should ensure that the impact of process improvement at every organizational level is analyzed so that those which required improvement are attended to. Here is a video about finance process improvement I would like to share.
Hello, and welcome to Finance Process Improvement in 10 slides. I'm Ross Maynard, a Fellow of the Chartered Institute of Management Accountants. Okay, as you already know, I'm sure, your finance team are expensive. They're highly skilled and extremely. So why are you wasting their valuable skills on day-to-day transactions? With increasingly complex business processes come increasingly costly finance processes. And at the same time, expectations on finance are increasing. Business processes are becoming more complex. Globalization means larger marketplaces, but also different demands from different markets. There's more regulation coming on board. The business needs to make faster decisions. The finance team must change to keep up with all of this, but you cannot just keep on adding cost. So it's time to look at your finance processes, to streamline them and to improve their efficiency, whilst at the same time maintaining financial control. The fact is that all finance processes contain waste. Over time, the waste in the finance process builds up, and this increases the cost of the finance process, and it doesn't benefit anyone. Some examples of this waste include rekeying between different IT systems if work's transferred, incomplete information available at the start of the process, handoffs between teams and departments, correcting or reworking previous errors, waiting for sign-offs and authorizations. And the two sort of groups of things which take time in finance processes are firstly transactions, we need to minimize those, and also delays and queues, we need to eliminate those. Where would you like your finance processes to be? What would be the objective for your finance process improvement? Well, I would like to think that you wanted finance processes that were focused on the customer and designed to meet specific customer expectations. You want finance processes where work was completed right the first time without the need for backtracking or requesting additional information. Where information flowed through the processes with few interruptions and little backtracking or double checking. Where information was timely, relevant and accurate and understandable by the end user for their decision making. And information that supported the resolution of process problems. Now, the thing to know is that improvement is a people issue. Tools and methodologies are all very well, but ultimately it is the people in the process that are best placed to understand its problems and its constraints. Processes are improved by people working together using problem-solving tools. So creating a culture of improvement is necessary and important, and this is about people feeling free to raise issues and concerns, knowing that their concerns will be listened to and acted upon. Improvement in this environment becomes the responsibility of the team. They improve their own process. Managers become facilitators who provide support training as necessary. So the most important thing in finance process improvement is to work as a team. Who are the customers of the process and what do they need from it? How does the process currently meet those needs? How effectively is it? How does it currently work? Where are the delays, the risk points and the errors? Bearing those two things in mind, how can we improve the process? How can we reduce risk, errors and delays? So how do we get there? Well, I have a sort of a three-step mini methodology here. Firstly, and the team should choose a process to start work on. Identify the customers of that process and identify the purpose of the process for the customer. What do they require from the process? Then you should study and map the process in detail so that you identify and understand the barriers to achieving this purpose for the customer. And then work with the process team to remove the barriers and fix the problems. Managers should actively facilitate and support improvement. So in summary, to improve your finance processes, listen to your people. They are the people that know the process, they know its problems and its constraints. Understand that the barriers that they face in working the process, and provide the skills and support that they need to improve things. Thank you. That was Finance Process Improvement in 10 slides.
Thanks for watching.